Guys. Hi, Mariah. Okay, I'm here a couple minutes early. I need one or a few of you to help me with these screens. Just want to make sure that. And if a couple of you could turn on your video, that would be awesome. So I can give me thumbs up. Let me know how things are going. Can somebody turn on your video and let me know? You can see the screens okay? Nobody wants to turn on their video because you have your pajamas on? All right. All right, it's 8 o'clock. Good morning. This lesson is going to be a little bit more formal than the last lesson we did. Thank you so much for turning on your video so I can see you. Kim, can you see the boards okay? Yes, okay. Anyhow, today I'm actually going to teach a lesson in 15.1. You've had it for a while, so some of you have turned in the assignment, but if you noticed, I added to the assignment, obviously, because I'm only going to be seeing you twice a week. You are expected to do work every day in this class, just like you did when you were at school. So make sure that you're not blowing off any days. Thank you so much for those of you who turned on your video, and I appreciate you all turning off your microphones. So if you can float to the bottom and turn off the mic. I want to go over a few housekeeping things here. First of all, remember that you're attending 2 meetings a week. Those meetings are on Monday and Thursday at 8 o'clock. Also, your workshop, which can run a bunch of different ways, will be on Wednesdays at 9:05. The reason why I started promptly at 8 today is because this meeting is being recorded, and I have so much to do that I'm not doing any editing of the videos. Can you guys please turn off your microphones? I'm getting a lot of static from about 50 people. So if you could just float to the bottom and turn off your microphones, that would be great. I want to go over in my syllabus a couple things, the weekly meeting expectations. So if you didn't have the chance to read it because you're bombarded by a bunch of information right now, I just want to go through this. Make sure you're on time. I want to start promptly. So in my syllabus, I'm saying that I might start 10 minutes early, but that probably won't happen until I start editing the videos. I don't want to spend 10 minutes of idle time with the videos. What you want to do when you join, can you guys turn off your microphones? Thank you. Float across the bottom of the screen and turn off your mic when you join the meeting. You only want to turn on your microphone when I do an example, and I'll turn to you and say, do you have any questions? This is one of the reasons why we're doing this interactively, so that you can talk to me. So you're welcome to turn on your microphone. Don't forget to do that so I can hear you, and then ask the question when instructed to do so. You can turn off your video, like I said, at the bottom, but I really appreciate all of you who are showing me your lovely faces this morning. I love you guys so much. It's good to see you, and it does help me tremendously. In case I ask you something, you can give me a nod, or you can give me a thumbs up or something. And make sure you're engaged. All right, and what I mean by that is don't be messing with unnecessary things. Be prepared to ask questions regarding the assignments or the lesson, and be ready to take notes. Now, you do have these notes because before we left for spring break, you picked up these notes, but in the future, you won't have the notes. And so you will need to take notes. So you want to make sure that you have everything you need for that. And I'll mention more of that in a minute. Make sure you sit close to the screen so I can hear and see you. And make sure you put your phones away. And I'm talking specifically in regards to Instagram, Snapchat, Twitter, TikTok, everything else that's out there. Try to just avoid that when I'm presenting the lesson. Do not check texts and emails not pertaining to the meeting. I know right now people are trying to help people get situated, but we've gone through a lot now to get everybody on board. So we're going to have to do that at another time now. So this is all business when we have a class meeting. Also try to, obviously you can drink water, but try not to eat and do other things. Try to treat this just like it would be if you were in my classroom at school. The required daily materials are just like that were in your original syllabus. You need to have notebook paper, obviously, when it's important to start writing. When you don't have the notes, you need a pencil, no pens. If you have to go back and erase something, I want the pencil. You do have to have a 3-ring binder. So if you're wondering, oh, you know, I don't need a 3-ring binder. Yes, you do. Because if I start flipping through things quickly, you're going to want to be organized. You're going to need your calculator nearby because things will run like the classroom when I'm dealing with the calculator. And you want to have highlighters and or colored pens. All right. As far as the class meetings go, you are required to attend the class meetings twice a week, like I said, via WebEx. I just got a message the other day that they got the recording started on Google Meets. I'm like a little late, but we'll see how that goes in the future. I wish I had known that earlier. In class meetings, I will teach lessons and review material. Assignments will be due. I'm usually twice a week, so just a reminder that on Friday, I need the verification letter. It's very important that you do this because I'm trying to see if you can take a picture of something and send it to Google Classroom. You may have to send your scratch paper for exams this way. So there's a reason why I do everything that I do. And so you're going to have to be able to take pictures of things and send them to me, especially if it's an exam later on. Recorded lessons can be reviewed on my YouTube channel. And I do have a link to that in the video section of your classroom. I am uploading videos right now, and so hopefully you've gone there just to see if you can see something. If there's an extenuating circumstance where you must miss a meeting, I know there are some conflicts with classes right now, and I do understand that, but I try to do the best I could in the way they set up this schedule, and so I'm not going to go into that, but I apologize if you're having a conflict with another class, but there was just nothing else I could do. I don't want to teach 3 separate classes when I can teach my Algebra 2 students at once, and I'm able to spend time figuring out this technology to best teach you. So if there's an extenuating circumstance where you have to miss a meeting, you must discuss this with me so I know what's going on. Otherwise, I expect you to join the meeting. So it's no problem. We are trying to iron out the kinks, so just let me know. And then I already talked about the verification letter. All right, let's start the lesson, okay? Some of you, I know you've looked at this already, but we're getting into lesson 15.1, which is defining and evaluating a logarithmic function. You know a lot about functions already. I do recommend that you do the Explore because it's going back to how we graph. We're going to use the same order for graphing. And it's a little different, but shouldn't have a problem with it once I explain it. This is California California Common Core Standard F.BF.5 plus. So this right here is an extension, and this is an extension for the honors, Algebra 2. All right. So basically, if you looked at the math on the spot videos, and I did encourage you recently to make sure you use your My HRW because there's math on the spot videos, and there's a lot of help in there. There's a lot of resources in there. So take advantage of that. Logarithmic function is the inverse of an exponential function. So just like the square root function is the inverse of the parabola when it's restricted domain, the logarithm is the inverse of the exponential. So let's take a look at this. We're just going to start from the beginning here. Let's look at an exponential function. So if you have f of x is equal to 2 to the x, you should know that. Just say it to yourself. Is it exponential growth or is it exponential decay? Okay, you're right. It's exponential growth because of this number being greater than 1. And so if we look at the inverse, which is f inverse of x is equal to log base 2 of x. Now, I want to talk about this for a minute because this is very important. And so I'm just going to stop for a minute and interject something. When you look at the logarithm, there's 3 different levels. And what I mean by that is sometimes you have a subscript and a superscript, and sometimes you have a subscript. Do not confuse me. One time the district sent a final one year and the final looked like this. And I refused to give the final. So I called the district, the director of curriculum. I said, I'm not giving that. This is going to confuse my students. We don't know what you're trying to say. So don't be really careful about your notation. I'm talking specifically about an exam. So the way you would read this is log base 2 of x cubed. So can you say that to yourself, please, out loud? Log base 2 of x cubed. Say it again, please. Log base 2 of x cubed. Now, while I'm talking about this, I want to talk about a common logarithm real quick, and I'll get to that. But if you see something like this, this is not log base nothing of x. There's an invisible 10 there, and you're not going to see it. So don't get confused about it. In this lesson today, you may see me write it, but you're not going to see it in your book. So the way you would read this is log base 10 of x. So if you don't see anything, just like 1x is equal to x, we don't say 1x. We know there's a 1 implied in front of the x. So when you read this, you would say log base 10 of x. How would you read that? Say it to yourself. Okay, say it with me. Log base 10 of x. One more time. Log base 10 of x. Okay. I will ask as we go along if you have any questions periodically. So if you have questions, just write them down. All right, now. If we want to graph the logarithm, we can say that this is y is equal to log base 2 of x. So we're going to use transformations for this, just like we've done with the other functions. And so this is the trickiest part. And if you can get this, you're going to be good. What we want to do is we want to graph 2 points, but let me show you what the logarithm looks like. All right. Remember the exponential? Remember the exponential growth went like this? And it had a horizontal asymptote. Well, now the logarithm, in fact, let me just do it in another color. So this would be your, well, I kind of didn't graph it exactly. Just pretend I graphed this correctly. The logarithm is going to have a vertical asymptote at x equals 0. And it is going to flip across the identity. So let me just draw the identity real quick. So remember the identity is y equals x. This might be a little off because I didn't graph the actual, maybe I will graph it. So if you pick the points for exponential growth, if you put a 0 in, you would have, what, 0 up 1? And if you put a 1 in, you would have right 1 up 2. There I have the actual graph now. I'm drawing it dotted because it's not really there. So here's the trickiest thing. what numbers do you think you're going to put in here? Because we always love to put 0. But guess what? You can't put 0 in here because we don't know anything about it. And we want to be able to put numbers in that we can figure this out in our head. So what we're going to do is we're going to put a 1 in. And there's a property that says that if you have log base b of 1, the answer is always 0. And these properties are not going to be introduced until the next section, but I'm going to introduce them now because it's going to help us out extensively in this lesson. So this right here is a property that you're going to want to know. This is a logarithmic property. So log base b of anything is 0. So for example, log base b of 3 is 0. I'm sorry, log base 1, excuse me, let me correct myself. Log base anything of 1 is 0. So let me repeat that. Log base 3 of 1 is 0. Log base 5 of 1 is 0. Log base a half of 1 is 0. Log base 12 of 1 is 0, so on and so forth. Okay, the next property that I want to show you today, and I'm going to be teaching these notes a little bit differently because I want to show you the way I'm going to do it today is better than the notes. There's another property that says that log base b of b to the x equals x. So I want you to notice this. You see the base of the logarithm matching the base of the exponent? They undo each other because they're inverses. So see how if the base of the logarithm matches the base of the exponent, it's just a power. So for example, if this was log base 7 of 7 cubed, the answer is 3. If this is log base a half of a half to 100, the answer is 100. So as long as the base of the logarithm matches the base of the exponent, this is going to be the answer. Now I wanted you to know this because of this. Now watch. If you have log base 2 of 1, we can use this property and say that the y value is 0. For the next one, it's like, okay, what should we pick? What should we pick? If we pick the base of the logarithm, so if the base of the logarithm was 7, we'd pick 7. If the base of the logarithm wasn't there, it's 10. So you would pick 10. So we come back to this property. What's log base 2 of 2 to the 1? See, log base 2 of 2 to the 1 would be 1. So we're going to graph those. This is right 1, 0, and this is right 2, up 1. And do you notice anything here? If we run the graph along the asymptote, ta-da, the inverse. So this is a reflection of the exponential growth function, y equals 2bx. So this is your inverse. All right, now I'm going to stop for a second, and I want to know, are there any questions about this little situation here? So in other words, you're just like your points were different for the exponential growth and decay, your points are going to be different for the logarithm because of the base. So the points are going to change in regards to whatever base you have of the logarithm. All right, now if you want to ask me a question, go ahead and unmic yourself and ask me. Otherwise, I'm going to go on. Okay, can I see a thumbs up if you guys are good? Okay, thank you. Now, this is wonderful, isn't it? I already knew this was going to happen, so I'm prepared with all kinds of chemicals. I don't know if it's because it's cold or just this board. Oh, the water's working good though. I could just go to the other board, but just like at school, for some reason, I like to hover on one board, which is ridiculous. But all right, so I'm going to give you a definition now. If you have, this is exponential. I'm not going to write that down. It's already in your notes. If you have b to the x equals a, the logarithm is going to be log base b of a equals x. Now, this is very important to know because one of the standards says that you guys can go from exponential to logarithmic, from logarithmic to exponential, and that's one of your exercises in your lesson. So notice that the base, this is the most important thing, notice that the base of the exponent is the base of the logarithm. So just make sure you know this. I'm going to say a couple other things here. First of all, in this case, b has to be greater than 0, and b cannot be 1. Okay, so let's do a couple of examples with this really quick. For example, and this is in my notes, 2 cubed we know is 8. If they ask you to write this in logarithmic form, what would you write? Well, the first thing you're going to write is the word log. And then you want to do the base of the logarithm. Now, the base of the logarithm would be the base of the exponent. So what's the base of the logarithm? Say it to yourself. Yeah. So log base 2, and then you're not going to put the power. The power is going to be the answer. So it'd be log base 2 of 8 equals 3. And notice the levels here. Notice that the 8 is on the level of the logarithm, is on the level of the 3, and 2 is a subscript. Be careful of your notation. You could confuse yourself with improper notation. So let's go backwards now. Not going to do all of these. If you have log base 6 of 1, we know from what I just told you, that property, log base b of 1 equals 0, you know the answer is 0, right? Because any base of 1 is 0. So if I asked you to write this in exponential form, what's the base of the exponent? It's the base of a logarithm, which is what? So 6 to the 0 equals 1. It's like, oh yeah, we know that. We know that. We already knew that. So I just proved that what I was saying about that was true by doing it backwards. I can do more of these later at the end if you want me to, but I'm going to stop with that. But you are required to be able to write exponential form in logarithmic form and logarithmic form in exponential form. All right, now I will go over to that board. I'm just working my way over there because I'm going to get tired of spraying the board. Oh, look, good that time. This next part in your notes, I'm going to teach it differently because I showed you these properties now, so we're not going to do this crazy work that they're doing here. So you're welcome to do it this way, but I wouldn't. Let me show you something. And in this example, they put a base 10, but normally, like I said, you're not going to see it. It's going to be invisible. And they want you to evaluate these various things. So I'm going to evaluate one of them. The first one is they want you to find f of 1,000. So you know how to do this. This would be f of 1,000 is equal to log base. I'm not going to put that 10 there because I'm going to try to get you used to not doing that. Well, I'll do it on this first one. After this, I won't. Of 1,000. So what I'm going to do is say this is y, and I'm going to match up the base and base of the logarithm and the base of the exponent so I can use that property log base b of b to the x equals x. So watch this. Log base 10 of 10 cubed is 3. That's a lot better than what you have in your notes, right? So they should have done this at the very beginning. They should have put the properties first. That's okay though. So f of 1,000 is equal to, I'll do another one. I'll do, this was A, I think. I'll do C. So in C, they have the same problem. They want you to evaluate f of radical 10. Now remember, we were trying to get these bases to be the same. So if you have log base 10 of radical 10, we don't want that. So remember that in the past when you had to write a radical using irrational exponents, that's what you're going to do. So this would be log base 10 of 10 to the 1/2. Therefore, using our little property here, log base b of b to the x equals x. So f of radical 10 is equal to 1/2. So I hope you like this better than what's in my notes. And like I said, if he had introduced the properties first, we would have never had to mess with that other thing. But anyhow, I couldn't wait to tell you that one. Doing pretty good on time. I'm going to go to the next objective, objective 3. Now remember, you could go to my HRW and you can get help with these different objectives. So the help that you're getting is matching to the objectives that I'm giving in my lessons. So that's going to be under, I think it's under resources, videos. I did come over here. It doesn't want to erase. Wouldn't be so bad if I wasn't so particular about the boards being perfectly white. Wish I wasn't like that. All right, so I want to talk about the common logarithm. I've already mentioned this, that log base 10 of x. You are not going to see it like that. You're going to see it like this. Log base 10 of x. It's invisible. Some of you in science may have already dealt with a natural logarithm. I know this is in your notes, but I'm talking about it. I am aware that it looks like my marker's cutting out, but this is a brand new marker. It's just what you're seeing. The natural log looks like this, log base e of x, but you're not going to see it like that. So you're going to see it like this. And this is the most confusing things to students. I'm not sure why, but just know that when you see that, that's log base e of x. All right, so what is this class? Log base e of x, right? What is it? Log base e of x. So that right there is your natural logarithm. All right, so both of these are on the calculator. So if you look at your calculator, I think it's on the left. This is log on the calculator, and this is ln. It's not in. Some people write in. That's ln for natural log. So when you're asked to use a calculator for these, it's real simple. Notice that you don't have a log base 5 on your calculator. You don't have a log base 7. Well, on the newer calculators, you can put the base in, but we're going to assume that you only have these 2 keys. So I'm going to show you later on how to do a change of base so you can use your calculator. But we're going to assume that your calculator doesn't have a base different than 10 and e. All right. So it's pretty simple. If you wanted to put this in the calculator, and hopefully you have your calculator, you would just put log of 13 and get your answer. It's about 1.11394 and so on. I would tell you how to round. So let's do another one. Let's see. How about the natural log of 0.42? So you would find the natural log on your calculator and put that in. So the natural log of 4.2, or 0.42, excuse me, would be what? It's negative 0.8675. That. So pretty simple. I haven't asked for any questions yet, so I will be asking for questions after. I want to do two application problems. The first one is chemistry. I want to show you how easy it is to do these problems in chemistry if you know math. By the way, Algebra 2 should be a prerequisite for chemistry. So some things are taught before you're actually given a lesson in Algebra 2. So it used to be a prerequisite, but they stopped doing that for some reason. All right, so what I want to do, look on page 752 of your notes. You don't have that, huh? Do you have your book? You do have it. So you do have I asked you to rip out these pages. So that's going to be an issue in the future when I refer to problems, but I'll read the problems to you regardless, okay? This is on page 752. The acidity level, or pH, of a liquid is given by the formula pH equals, where H plus is the concentration in moles per liter of hydrogen ions in the liquid. In a typical chlorinated swimming pool, the concentration of hydrogen ions ranges. Now, the key word here is ranges. So you guys know what a range is. You've been doing range since elementary school. So a range is the difference between a high number and a low number. So you haven't seen it quite like this, but you do know what range is. So it says the typical chlorinated swimming pool, the concentration of hydrogen ions ranges from that number of moles per liter to that other number of moles per liter. What is the range of the pH for a typical swimming pool? So all we're going to do is write down the formula. It's what? pH equals log base 10 of 1 divided by a hydrogen ion concentration. I'm going to put this in a box. So what we want to do is we want to compute each one of these concentrations. So the first one is going to be log base 10 of 1 divided by, is it 6.31 in scientific notation, times 10 to the negative 8. So just a comment here. This is a very small number. And see how we're using scientific notation to represent it? It would be crazy if we brought this out 0.00000. You know, it doesn't make any sense to do it that way. So thank goodness for scientific notation. So because we're working with decimals, just put it in your calculator. Be careful how you put in your calculator though. You want to put your log base 10 and then 1 divided by this. I would be really careful of this number. Make sure I would put this in parentheses on the calculator. So I would put log base 10 of 1 and put this in parentheses. So when this, and pay attention to me here. So this division is dividing that whole number. If you don't be careful about how you put this in the calculator, it's going to be 1 divided by this, and then it's going to multiply by that, and that's not what you want. You want 1 divided by that whole number. If you look at my notes, you can see that I did this first, then took the logarithm. You can do it either way. If you're really good, put that all in at once. If you want to do this first and then put the log with it, just do it however you want where you won't make a mistake on the calculator. Anyhow, this turns out to be about 7.2. Okay, can you nod your head or give me a thumbs up if you got that? Did you guys get that number? Yeah? Okay, good. All right. And so now we're going to calculate the other one. So it's equal to log base 10 of 1 divided by 1.58 times 10 to the negative 8. So once again, be careful how you put this in the calculator. I would put log parenthesis 1, put this number in parentheses so it works correctly. And you're going to get 7.8. So I'm not going to write this down, but what you would say then, this is the range. You would say the pH of the swimming pool ranges from 7.2 to 7.8. The next problem is a little more complicated, but I want to open this up for discussion right now. Does anybody want to ask me a question about this? Any questions about the calculator or this problem? Clear as mud. Okay. I never in a million years thought that I would be teaching one of my lessons in socks. So I had to share that with you. Just so weird. B, or the application B on page 752. This looks like a biology problem. I hated biology when I was in high school. I had 2 football friends and they always helped me dissect the crawfish and the whatever else we were doing. I hated that. Okay, ready? The Lactobacillus acidophilus is one of the bacteria used to turn milk into yogurt. The population P of a colony of 3,500 bacteria at time T in minutes. Now usually T is in hours, but in this particular formula, it's in minutes, can be modeled by that function. How long does it take the population? 1,792,000. Okay, check out this problem, you guys. They're saying P of T is equal to 3,500 They gave this to you, is that correct? Is it T? Can't even see, it's dark in here. Is it T over 73? Let me get my lid. All right, so the question is, how long does it take the population to reach? So what we're solving for here is time. So we're just going to say that this is P for the population, and we're going to solve for time. Now, do you notice that this is an exponential function? Because we have the exponent T, and that's what we're trying to find. So basically, we want to get them down from there. So the question is, how do we get them down from there? Well, we're going to isolate the variable. So we're going to divide both sides by 3,500. So what we get here is P over 3,500 is equal to 2 to the T over 73. By the way, if you ever see me making a mistake in these presentations, make sure you unmic yourself and let me know. I don't want to go through and work the whole problem and find out that I made a mistake on the second step. Okay, now, I didn't put this in my notes. If you're wondering what's going on, in order to get him down, we're going to undo the exponent. So remember what I said here, that we want to do the inverse to get him down. So what we want to do is take a log base 2 to both sides. I'll show you, hold on. See this? If this base was 7, I would have taken the log base 7 to both sides. If this base was 1/2, I would have taken the log base 1/2 of both sides. So whatever the base of the exponent is, that's what you're going to make the base of the logarithm. Because see how we have log base b of b to the x? So we're able to get him down by doing the inverse. So we did the inverse of the exponent to get him down. So what we have now is that cancels out t over 73. And over here, this was p divided by 3,500. I hope you can see all the different levels. This is a subscript. That's the same level as the log, and that's the a superscript. So subscript, same level as the log and a superscript. And so over here is just it's a big mess. You just leave that alone. It's a mess. Just leave it. And so I'll rewrite it. And now solve for t. So to solve for t, make sure you put that in parentheses. You're going to multiply both sides by 73. So they want us to find time. We did. And I'm showing you the change of base here. I don't know if I want to do that or not, but basically, show you this. I'm not sure if I'm going to show you this. Okay, so this is the answer. You could leave it like that if you but see, here's the problem. We can't put this in the calculator because we don't have a base 2. So you are going to be required to use a change of base. All right, now, if you were wondering, hey, why didn't she put in the p right away? Because I didn't want to mess with that big number. So I waited to put that number in. So I'm going to put the number in now. So p, they told us, was that 1,792,000. I'm going to put that in. So this is going to be 73 log base 2 of 1,792,000 divided by 3,500. Now I'm going to show you how to put this in the calculator, okay? What you're going to have to do, and can you see my screen if I write here? Hopefully. Okay. What you're going to want to do is you're going to want to use this thing called change of base. And so basically what we're going to do, I'm going to show you how to change base 2 to base 10. It's real simple. I'm not even going to write down the definition. I'm just going to, maybe I'll show you over here real quick before I finish the problem. Okay, so for example, if you have log base 2 of 5, if you want to put this in the calculator, all you do, but make sure you don't mess up the order, it's going to be log base 10 of 5 divided by log base 10 of 2. Just put that in the calculator. I'm not going to do it. If you wanted log base 1/2 of 7, the change of base is just log base 10 of 7 divided by log base 10. of a half. So back to this, if we were going to do the change of base, what would this be? This is going to be log base 10 of 1,792,000 divided by log base 10 of 3,500. Still, there goes my marker. It's exactly equal to. And what I would do, if I were you, is I would simplify this down by canceling those zeros and simplify it down so you're not putting big numbers in the calculator. Let me go over here. I'm doing super good with time, which I'm happy about. Scared that all this erasing was going to take a lot of time. Oh, I forgot my 73. All right, so I would simplify this down. So the trailing zeros, these are going to cancel. He's going to cancel with him. He's going to cancel with him. And then you can see that these are divisible by, I think 35. Does 35 go into that? Well, I think I can see my notes. I think my notes might not be right. Might be right. I don't have my calculator here. That's the one thing I forgot. But anyhow, you would simplify it down. Sorry about that. I'll make sure I have my calculator here. I don't want to run and get it right now. It turns out to be 73 times 9. After this lesson, if you need me to work this out, I will. But hopefully there's no issue with it. So the time. What's that?
It's 512. 35 times 512 is 17920.
Okay, thank you. Thanks, Clay. So that's you, right?
Yeah.
Okay, now what is this? This is 12 right here?
512.
512 right here?
Yeah.
No, it'd be 73 log base 2 times 512. It'd be 73 times 9 still.
Are my notes right?
Yeah.
Oh, I see what I did. Okay. I see what I did. I changed the base. I'm not looking at I'm not following my notes. I changed the base up here. Okay. Instead of changing the base right here, you want to change the base at the end. So you could just keep the log base 2. I'll do it again because I have time. Wow, things were going so smoothly there for a minute. So you have to fast forward through this if you watch the recording. Let's do this again. Keep the base 2 right now. So you have log base 2 of that stuff. So cancel right here. So cancel those zeros and then simplify that. So it'd be log base 2 of 512. Don't do the change of base until the end. I think we're good right now. And so now we're going to do the change of base now that it's simplified. So it's going to be t is equal to 73. And we'll do the change of base. It'd be log base 10 of 512 divided by log base 10 of 2. I think we're okay now. Back. The train went off the tracks for a second, but we're back. You put that in the calculator, and you should get 9. So t is equal to 657. So what you would see is the bacteria will reach 1,792,000 in 657 minutes. And if you had, nobody wants to hear that in real life. You would do it in hours. So nobody understands 657 minutes. So you would convert that to 11 hours. They'd understand that. Okay, what I'm going to do right now is I'm going to stop the recording. That is the lesson for today. If you notice, I have the verification letter that's due on Friday. Make sure you get it to me. Also, I have this assignment due, I think, on Monday night. So Monday, I'll be teaching a new lesson. In between then, if you have difficulties, make sure you contact me and I can work with you. But I'm not going to do a lot of answering questions at the beginning like we usually do in class because I need the time to teach the lessons. So I'll stop periodically throughout the lessons, but we're not going to be doing a bunch of problems. That's going to have to be done at any other time you want. Okay, I'm going to turn off the recording and I will see you all at another time, but I am going to hang out for questions now.